Awesome. Thanks for joining us again here today. We're coming in here live from the AWS Loft in San Francisco. We're here at the Loft today covering a whole range of topics around serverless. If you missed us here in the previous hour, we just did an initial view into Lambda and serverless applications. This next section here, we're going to be taking it a little bit further and doing a deep dive into something called AWS SAM and the AWS SAM CLI. And again, we're here all day talking about serverless topics, and there's a lot of things that we're going to cover. For those of you who are just joining us, either both here physically in the Loft or virtually online here with Twitch, my name is Chris Munns. I am currently a principal and the lead developer advocate for serverless at AWS. I am based in New York City and have been at AWS here for a little over 6.5 years across a couple of different roles, primarily coming out of the startup space in New York City, working for companies such as Etsy and Meetup.com, and primarily as a DevOps person. But today I get to talk about this awesome space of serverless that is growing rapidly and really kind of transforming the industry to a degree. So why are we here today? Again, we've already been talking a lot about, about the serverless space and various aspects about it. This section here today, we're going to talk a bit about some of the tooling that we have here from AWS that can really simplify your life with building serverless applications. Again, there are just enough things about serverless that make it nuanced and different that having a purpose-built tool for building serverless applications can be really valuable. And so in the last session, I had a slide about some of the different frameworks that we had. And one of them in particular that we're going to focus on right now is my good squirrel friend here called SAM. And so we're going to talk here today about AWS SAM. So what SAM stands for is Serverless Application Model. This is, again, a tooling framework that we have here for serverless applications at AWS. It's been around now for just a little over a year and a half in total, I believe. And again, we're going to go really in depth here about it. So what SAM is it is built on top of another service that we have here at AWS called AWS CloudFormation. CloudFormation is a service that provides a template-driven way or document-based driven way for provisioning, managing, updating your infrastructure. And so you have a text document, it represents the resources inside of your infrastructure, and then you pass it to the service, and it goes and provisions those and manages those for you. Now what SAM does is provide some special capabilities specific just to serverless on top of CloudFormation. And so we have a couple of special resources. We have serverless functions, APIs, tables, and the layers and applications, which is a newer concept for us here. And it can support almost anything that CloudFormation supports today. Again, it's built on top of that. Now, SAM is an open source tool. So not only is the specification open source, but we'll talk about something later called the translator, which is also open sourced. And you can find out about SAM by going to aws.amazon.com/serverless. And almost everything we're going to cover here today gets mentioned there. Now, previously I mentioned how when we talk about a serverless application, there's kind of three main aspects to it. There is your invocation source. So today we've got over 40 services at AWS that can invoke Lambda. There is your Lambda function. And then there is what your Lambda function might need to be talking to. So databases, data stores, other endpoints on the internet. Now, imagine we wanted to provision these three things and manage them. So let's say we have an API-based workload. So we need to provision and manage an API gateway, our Lambda function. And let's say we have a DynamoDB table for storage of our data information. Now, with SAM, what we can do is create a document that looks just like this. This is about 20 or so lines of code. And let's break down what goes on inside of this. So in the first section, what we have here, the top two lines are considered the headers in CloudFormation. The first one, template format version, is just kind of a thing that tells CloudFormation that this is a CloudFormation template. The second line, though, here, transform, is really important to us here in this talk. Now, this transform says AWS : serverless dash, and then you see a date stamp there. Now, this tells the CloudFormation service that, oh, this is a special type of template file. I'm going to need to apply a transform to it. And what the transform is going to do is convert these special resources into raw CloudFormation. Down below here, then, we see two different resources that are defined. And I'll talk about the bottom one first in this case, because it's really, really basic. We have a resource that's named list table. It's of type AWS Serverless Simple Table. And what this represents is a DynamoDB table with a base 5 read and write units. Really, really straightforward, basic DynamoDB table. And that's all we need to do to define it. If we go up kind of to like the middle of this document, the kind of the main body of it, we see that we have a resource called getHTML function. It's of type serverless function, AWS serverless function. And then it has properties that are broken down into two areas. Now, the first four properties are really specific to a Lambda function. We have where the handler is. So we talked about on the previous session, the handler is what the service looks to invoke your code and inject the event into. We have the runtime, in this case, Node.js 6.10. We have where the code lives. We have a policy for my function. So this function has read-only access to DynamoDB. And then below that, we have this event structure. This event structure has a single resource called getHTML. It's of type API, and it has properties for proxy routing and the any method in HTTP. Now, what's going to come out of this is a Lambda function, an API gateway, stage and endpoint configured, my code put in that Lambda function, and a DynamoDB table. And then all of the resources and policies necessary to glue them together created for me. And so again, here it's about 17, 18 lines of code. Another way to think about this, and this is from an example that we have up in GitHub called SAM Farm, is that from, I believe here it's roughly lines 10 through 25, so 15 lines of code, gives you 7 different AWS resources. And so if you were to go through the console and go and create all of these, you'd be doing quite a lot of clicking. If you were doing these just from the CLI, you'd be quite a lot of CLI commands. But in this case, this roughly total 25 lines of code with a bunch of CloudFormation specific things here is going to give you those 7 resources. Now, when you transform this using CloudFormation behind the scenes to raw CloudFormation, this is about 70 or 80 lines of code. So it could quickly go 4 or 5x what you see here in this template if you were to do it in just raw CloudFormation. So this really, really, really simplifies and streamlines what's required in building and managing a serverless application. So let's go a little bit deeper here. So again, we have 5 special resources today inside of SAM templates that you can create. We have a serverless function, and we see here just a snippet of actually what's available for a function. We can define almost any aspect or attribute about our Lambda function, its event sources, environment variables, and all sorts of information about it. We have an API definition, so this represents an API gateway stage, and we can configure things like caching. We can also configure things like authorization and endpoint configuration like cores and headers and other stuff like that. We have a simple table, which is, again, a DynamoDB table. And DynamoDB table, we have a couple of basic attributes here that you can configure. We have something called a layer version, and we're going to talk about layers here again after lunch. But this is an exciting new capability inside of Lambda today. And then we have a serverless application. And so one other thing that we announced back at reInvent, which we'll talk a little bit deeper about here today, is we already saw today in the Serverless Application Repository that I could easily go and launch an application. What we can actually do now is something called nested applications, which allows me to have one serverless application reference an existing application in the application repo as if they were basically one entity. So when I go to deploy my application, I could say, oh, my application also depends on this other app in SAR, and it'll pull that down and install that in my account the same way. So this allows me to define that other application as part of my application. Now, in terms of functions and event sources, we've got the ability to configure almost any event source that you have here. We're not going to go through all of these here today, but it's all in the documentation for SAM. And so each event might have some specific properties. We see for an S3 bucket, we can specify, or for an S3 object, we can specify just the bucket. But we could also filter on prefix or suffix, say which specific S3 event we care about, puts or deletes, for example. And so you can really get fine-grained as to what your event trigger is. I mentioned before you can use CloudWatch events to replace cron jobs. And for this, you can actually just pass in the true cron syntax for when a function should be executed. And so per all the different services that we have, you can get all of that configuration. Now, what SAM will do in some case is actually configure that resource for you. So if that resource doesn't exist, it will go and create an S3 bucket for you. For others, it will expect you to pass in an existing resource. Let's talk a little bit more about SAM from the CloudFormation side of things. So again, SAM is built atop of CloudFormation. This is a CloudFormation template. Don't expect any of you to be able to read what's in there. But what I do want you to get from it is that there are a couple of different kind of sections of code that can exist inside of a CloudFormation template that have different capabilities. So we already talked about the headers, and we saw that we had a header that said this is a CloudFormation template. It has a transform, and that's something that you need in pretty much every CloudFormation template and SAM template that you're going to create. But then we have other capabilities that can add a lot of interesting power to this. So we have a concept of parameters, and apologies here if the lighting makes it a little hard to see this, but these are parameters are things that are passed in at execution time of this template. So at provision time, you could pass in information. Maybe, let's say, a developer's name. You could pass in an environment. You could pass in whatever information you might need to that could add some dynamicness to this template. We have mappings. So in this case, mappings are, you could think of it as a predefined case statement or switch statement inside of your template. We have conditionals, which are similar to mappings, but in the context basically allow you to say that a resource should or shouldn't be created given some other context. So in production, we will always do something HA, but in dev, we won't, type of a thing. There's the resources, so that's kind of the meat of this document, the actual AWS resources that we're going to define. And then there are outputs. And so what outputs represent, much like it sounds, is what are the results of this template? And I might need those results to pass into another application stack, or to tell someone where they can find my application's endpoint or other information about it. And so these capabilities make CloudFormation really powerful from a provisioning tool standpoint. So again, we can mix in these various capabilities. We can launch other AWS resources or reference them. And there's other things like we'll talk about here in a moment, this concept of intrinsic functions, which are basically shortcuts inside of CloudFormation code that can do things like reference other resources, or split strings, or join strings, or do a number of other things that you can have here. There's something called imports and exports in CloudFormation, which is a bit too much to get into here today. But the long and short of it is that it allows you to define, essentially, inside of a region, a global namespace for resources that have been created. So I can create in one CloudFormation template something that I call proddb. And then in any other CloudFormation template or SAM template that I launch, I can reference that database just by saying, give me proddb. And it will tie that back to, say, like an RDS database or a DynamoDB table. And so again, I can get all of those things put together. And then lastly, for both SAM and CloudFormation, we support YAML or JSON. So pick your flavor, and you can do that. So let's tie this back into what we can do with Lambda. Now, inside of Lambda, we have a concept called environment variables. Pretty straightforward for any place else you've ever seen environment variables. In this case, these are represented from the underlying operating system on up. And so you could just use the native calls inside of whatever language you're using to get environment variables from the underlying operating system. So for example, here we show in Python, it's os.environ. And so what we could do with these is all sorts of different things. We can pass in key value pairs for feature flags, for credentials for databases or APIs. We can pass in all sorts of configuration information. We can optionally encrypt this if we want to. And so we can use these to add, again, further dynamicness to our code and keep us from doing things like hard coding in sensitive information, which you typically wouldn't want to do. Similarly, with API Gateway, we have a concept called stage variables. And so much kind of like Lambda environment variables, stage variables add this extra bit of dynamicness that can get passed down from a request to my backend, and then we can act on it and respond differently depending on what has been configured for this. So let's put these two things together, plus some SAM capabilities. So what I have here is an example of, think of this as one contiguous code file. So it kind of goes from the top of column 1 all the way down to the top of column 2. And so inside of this, I have a parameter defined called myEnvironment. It is of type string. It defaults to testing. And then I have allowed values, so I can specify only what can be passed into this parameter at execution time. So testing, staging, and prod. If you tried to pass it in banana, it's going to fail, right? It's only going to take these 3 values. I then have a mapping. So the mapping, again, you can think of as kind of a conditional switch statement. So for this, I have a mapping called special feature 1. And then we see that under special feature 1, for testing, staging, and production, I then have an attribute called status, and status is either on or off. And then if you go over the other column, you see that I have a serverless function defined and a serverless API defined. Now in the function, I pass in some environment variables. I pass in one that's literally just called environment, and that uses, again, what's called an intrinsic function, that exclamation ref for reference. And then it references my parameter called myEnvironment. Below that, you see something called special feature 1, essentially, as an environment variable. And now this uses an intrinsic function called find and map, which points to the mapping in this template. And it's a little bit more complex. It basically says, I'm using the map special feature 1, and I'm going to key off of the reference to my environment, and I'm looking for the attribute status. So the way that this will work out when it all gets spelled out is that the parameter that I add in for my environment from the template will get passed into my Lambda function as that. And so inside of my code, I might want to do something different for testing or staging or prod. And based on how I launch this stack of resources, it will do that different thing. As well, for the special feature aspect, in testing for this case, I have status set to on. But in production, I have status set to off. And maybe what I want to enable is some debugging output or context in testing and staging, but not in production. Or I'm testing an actual new feature in one of those, and so I want to control it that way. And so again, in this case, I'm assuming that my code is just going to look for that environment variable, and that I'm going to pass that in at execution time. OK. Now, you can combine this to do some other interesting things. So with Lambda, we have a concept of versions. Pretty straightforward. As you launch a new version of your code, it's going to correspond to a number value that increments automatically. I could then assign what's called an alias to that version. So we see here under my function, I have 8 versions that I have deployed. 3 of them have aliases. So I see version 3 is alias to currently to prod. Version 6 is alias to beta. Version 8 is alias to dev. Now, what I can do on the API gateway side is using stage variables, say, based on the stage variable, align to the alias of the Lambda function. And so where I pass in for the stage variable of Lambda alias prod, it's going to point to my prod Lambda function and so on. So pretty straightforward. I can have different environments. I can have the same configuration, generally speaking, when I deploy these resources. And then based on these environment variables, it will do different things. Now, when I want to go ahead and make it so that version 6 is now going to leave beta and be promoted to prod, it's pretty easy. I can take the alias for prod, point it at version 6, and all of my traffic will just swap over and cut over to that. But this can be problematic. And so often what you want to do is actually test this functionality slowly. You want to slowly roll out the change to your function so that you don't maybe cause an impact to all your customers. And so in Lambda, we have a capability called alias traffic shifting. And much like the name sounds, what it allows me to do is shift a portion of my traffic over to a new version with the same alias. So we see here, I have now configured version 6 to also have the alias of prod. But I'm only going to say only send 5% of traffic towards it. Now, on my API gateway for the prod stage that has the stage variable of Lambda alias equals prod, I don't have to do anything. My API gateway stays exactly the same. And so API requests are going to come in, and 5% of them are going to go to this new version. And now I can do this by hand. I can run the command line tools and bump this and move it up and do all of that. Or I can do this with SAM. And so inside of SAM, we have a couple of capabilities that make what we call inside of SAM safe deployments really, really easy. And it's basically just these couple of lines of code right here that I'm going to go into. So the first is that inside of SAM, we have a capability that you can have for your functions called auto-publish alias. Basically what this says is that every time that I deploy this function, I'm going to assign the alias of whatever I'm going to assign it to in here. And now in the previous code snippet, it's a little hard to see maybe here. It's kind of the top line of the highlighted box. But you see that I'm going to assign auto-publish alias to whatever I've assigned this environment to. So if it was staging, or testing or prod, that's going to be the alias for my function, just like we see aliases for aligned here. So that basically enables safe deployments for me. Then I have a deployment preference. And so in deployment preference here with SAM, we have a couple of predefined preferences that you can have. And you can think of these at the speed at which I'm going to attempt to deploy this function. And so we see here a concept of canaries. Canaries is a term that exists outside of Lambda. But basically, I'm going to shift just a certain percentage of traffic for a period of time. And then if everything is OK, then I'm going to shift the rest of my traffic. If not, then I'm going to roll it back. We also see here a linear preference. So in this case, linear preference is going to automatically increment the percentage of traffic over the window of time until I'm complete or I roll it back. And so we see here, for example, canary 10% 5 minutes. That means run 10% of the traffic for 5 minutes. If everything's good, ramp it up to 100. We see linear 10% every 2 minutes. And so every 2 minutes, it's going to increase the traffic by 10% until we get to 100%. And so with this model, I can deploy out new code, shift it out to a small percentage of my customer base, and we'll actually create specific logs and metrics for the version of your canary code so that you could go and compare them. That doesn't sound like a lot of fun. That sounds like a little bit of work to sit there and side by side watch those metrics and see how differently things are performing and if that's good or not. So the second part of this is that it supports the ability for you to align with your function alarms. And apologies, some of the colors got a little messed up here in this slide. But what I can do here is actually tie back this deployment to CloudWatch alarms. So I can have CloudWatch alarms on things like errors or latency or other metrics that are important to me in this function. And if for some way it trips that alarm, so latency gets too high, it will automatically stop and roll back this deployment for me. So we'll end the impact to my customers. And so you can define up to 10 different alarms today, and you can create custom alarms with CloudWatch that represent business logic metrics. Again, it could be the built-in metrics, things like latency or error rate and stuff like that. But this allows you to be able to automate this process of deploy out my code, test it. If things are good, go forward. If alarm triggers, automatically roll it back, and then I can deal with that. Going along with this, then we see this concept down here of hooks. So we have a pre-traffic hook and a post-traffic hook. Much like those names sound, they are things that are executed before the traffic is put on this function or after it. And so we can use these to say, put a message into Slack that says, hey, doing a deployment to prod, or updates a change management system, or calls off to a monitoring service, or calls off to another function to test this function and hit it with a number of requests and make sure that it works. So there's a lot of different things that you can do here. And again, the end goal is to make deployments really safe for your end customers and for your code. Another capability we have here in SAM is a concept called globals. So what we see here in this document, and again, imagine this is a single document running kind of top to bottom across these two columns, is that I have a section of my document called globals. It has a subsection called functions. And then inside of this are attributes that pertain to Lambda functions. So we see my runtime, where my code lives, my memory size, my timeout, et cetera. We then see 3 other serverless functions that are defined here. And it's pretty obvious. What they don't have in their definitions is the stuff that's in the globals. So imagine I had an API, and my API had 50 different Lambda functions in it. If I have globals defined, that's 50 less lines of code times however many things I have in globals that I don't have to define per function. And now, if you look here at the getBirds function, you'll see that it does have timeout specified. And this is basically that inside of the actual resource, you can override what's in a global. But again, right, the way that works the SAM template is each of these function lines of code, if it was raw CloudFormation, is going to be 3 to 4x what you see here in SAM. And then globals allow you to write even less SAM. So again, we're greatly reducing the lines of code that we need to manage this. And we're getting kind of the benefits of being able to standardize across an entire application some of these capabilities. Cool. Another thing that we have in SAM. So I mentioned earlier today about talking about security with Lambda. There's 2 main concepts. What can my function do, and who can invoke my function? Both of them really critical to get right and make sure you've got the right level of security in your function. So we have this concept called policy templates, and this impacts the policies for what your function can do. So what can it talk to inside of your infrastructure? And so in this case, I have a policy that is called SQS Polar Policy. It takes in a single attribute, which is a queue name. And in this case, I'm using the intrinsic function ref to reference the queue that you see at the very bottom of the slide. And now this single, kind of simple, really 2 lines of code will actually correspond out to a complete IAM policy that will be keyed directly to what it says here, basically, doing SQS polling. And so you'll see here kind of a snippet of this code. Kind of right in the middle there is the IAM policy that is really important for this. So for those of you who are not familiar, IAM, or Identity Access Management in AWS, is pretty much the core policy, rules, rights, grouping, user capability inside of AWS across the board. Like it impacts security across the entirety of the platform. And so per service that you're talking to, depending on what you're trying to do, there could be a lot of things to learn about this. It's kind of its own language in a sense. We see here that I'm giving this function via this policy basically 6 different rights specific to this one queue. And so this greatly, greatly simplifies this, right? 2 lines of code, 20 lines of code. 2 lines of code, 20 lines of code. So you can kind of get here the impact of this. Now we have close to, I think, 50 or so different predefined policies for you today. These cover things like only be able to read and write from a single DynamoDB table or a single S3 bucket, or only be able to read from this specific Kinesis stream. And so you can kind of think of it, so this link here, which hopefully still works, but if not, you can get to it from the documentation for SAM. This basically acts as a cheat sheet for IAM. If at all you're dealing with IAM and you've got to figure out how to configure it, these predefined templates are going to make it a lot easier for you. And then again, in SAM, you can reference it, and behind the scenes, we unpacked it for you. Cool. So let's go a little bit beyond the template here. So we've talked about various capabilities of the template. These are some of the big ones. There's some other little nuanced things that you can do. But you've crafted the most beautiful template in the world. You've painted the Mona Lisa of SAM template files. What do you do with it from there? The second part of SAM that we have is something that's now called the SAM CLI. When we first launched it, it was called SAM Local. And much like the name hinted at back then, the idea for the SAM CLI is that we allow you to run, debug, build, test Lambda functions locally on your laptop, on your desktop, on any place that you can run the CLI, which runs on Linux, Windows, Mac. It's just a Python application at the end of the day. And so this can become basically your interface into the serverless application world. And so you take your template file and your code base, and what SAM CLI can do is basically take those things, bundle them into a Docker container running locally on your workstation. It can mock API gateway for you, essentially giving you an API interface that you can test against. It can create a Lambda API for you, such that you can test your own code that interfaces with Lambda, or you can generate fake events from other services that would cause Lambda to be fired up. But it gives you all those capabilities. It actually can do quite a lot of things. So just a quick run through of where we stand today. And I'm going to show you a bunch of this here in a moment. But you can build application dependencies. You can package and deploy. You can do, again, local testing. You can create new serverless applications. You can tail logs from production. You can validate your template files. You can publish to the app repo. So a lot of things that you can do here from SAM CLI. And it's a toolkit that we're seeing being built into all sorts of other tools as well. So pretty cool thing to get started with and to play with here. Now, I mentioned application repository already before. We saw that I launched Magic 8-Ball from it. Again, this is a place where, so serverless app repo, in order to publish app to it, it has to have a SAM template. So it is a requirement for using the app repository. And it's part of the magic that helps make the app repository so simple to use when you want to launch applications. And so again, you need SAM in order to be able to use SAR today. So let's take a demo here and get out of slides for a bit. Okay. So in this case, I'm going to come over to Cloud9. So Cloud9 is a cloud-hosted IDE that we have here at AWS. Let me actually just really quick try to make these colors a little bit better for those of you who are in the room. And so, Cloud9 can be kind of the full, there we go. Again, a full cloud-based IDE. Let's see if I can just do, here, I'll just do that. Sorry, 1 second here. Let's see if this makes this a little bit easier. Kinda. 1 second here. Just do background color. Let's see if I just do that. Is that any easier for people to see if I make it a little bit bigger here in the room? Sort of. Okay. We'll take sort of for today, I guess. So Cloud9 managed IDE in the cloud. It interacts and is tied into AWS in a number of different ways. And this actually runs here in EC2. So you see that I'm on a terminal window in here for EC2 user. Now, this is, again, a full-fledged IDE. I can come in here, I can write and edit code and do all sorts of things. Now, inside of Cloud9, we actually already have SAM installed. And so I can come in here and just see that SAM is installed. I've got version 0.10 of the CLI. I can come in here and run help and see all of the various capabilities that we just saw on that previous slide. Now, assuming I'm in a completely blank environment, which in this case I am, I have nothing else going on inside of this environment here today, I can actually go and create a new serverless application. So I can run SAM init, and I'm just showing you here with the help structure. I can run SAM init and then pass in my runtime. I can run SAM init and pass in a GitHub URL, an HTTP path, all sorts of different things that are out there. And so we have a lot of companies that are sharing serverless applications via this way. Now I'm just going to come in and create a really basic application in Python 2.7. So I'm running SAM init --runtime Python 2.7. And you might notice here right above that we've got runtime support for all of the managed runtimes. We don't yet have support for the bring your own runtime. OK, so I ran SAM init --runtime Python 2.7. It came over here on the left in the file explorer, and it created this directory structure called SAM app. In here is a test directory, a hello world directory. I've got a README file, a template YAML, and a git ignore. The README basically explains everything that's inside here and what I would need to do to test this function. And so that's cool. The template file is an actual SAM template. Let me close some of these windows here. And so I see here that I have a global section. I have my resources. I have outputs. Inside of here, I have a single function definition. So this function definition has where my handler is, my runtime, environment variables, and then an API path for it. I can come here into Hello World and find my actual app code. So this is Python code. It's got basically some comments about how it works behind the scenes and what gets passed into it. And then if I come all the way to the bottom here, really what happens inside my handler is that it makes a call to a URL out on the internet, which is checkip.amazon.aws.com. And this is a tool you can use to pretty easily get your IP address from wherever you are. So it's going to call that, get my IP address from my function where it's running, and it's going to do much like in the first demonstration that I showed here today. It's going to spit out a response wrapped in JSON that says hello world and then my IP address for location. So now this application also has requirements for it. So it has some dependencies that need to be installed. In this case, it just has the requests dependency. So requests is a really popular Python library, and it is not currently installed here. So if I read the README, what it would tell me is that what I need to do is install that dependency before I can go forward. And so to do this, I can just from the root of this application type in SAM build. And so what SAM build is going to do is it's going to go and it's going to look at my SAM template. My SAM template says, oh, my function code is in the hello world directory. It's going to go and look in hello world directory, and it's going to say, OK, this is a Python application. So I'm looking to see if there's a requirements.txt file, which defines Python dependencies. And then if it is, I'm going to deploy this. I'm going to install those dependencies. So I ran that, and it created another directory here called .aws-sam, and inside that, a build directory. And inside that, a hello world function directory. And then you can see here kind of on the left-hand side of this, all of these other folders. And those are all of the dependencies and sub-dependencies of this function. And so that's all in there for me. I didn't have to run the pip command or deal with that myself. So I can go into this directory. And I have now in here again a template.yaml file. It's been slightly updated. And it tells me where my code is. It's now in this build directory, and what has to be done to execute it, and all of that. So I basically, at this point, have a ready-to-go application that could be tested with. And so I know this is an API. So let me go ahead and do SAM local start-API. Oops. and I'll reference the template file. OK. It's kind of jumbled here, but what's going to happen behind the scenes is that SAM CLI is going to take my code, fire it up in a Docker container running locally inside of this environment, and it makes available here on localhost :3000 my running application. So I can copy this, go over to another terminal window, and I can just curl this local interface. So now that failed, and I knew it would, because what I actually have to do here is go and look at my event, and my path is /hello. So I'm going to come back here, and I'm going to curl /hello. OK. So what I got back here now is my function actually running. So I got message hello world, and I got location, and I got the IP address that it shows this Lambda function running behind. If I come back to the first terminal window that I was in, again, apologies for some of the text here being just a little kind of hard to read in this, but what I see down below here is the actual execution taking place. And maybe it's worse if I highlight it. So I see a start to the request. I see an end of the request. I see a report. This is all the same information that Lambda would be giving me if I actually ran this in quote unquote production Lambda. I see also the log of the request. So it was basically just an API call to /hello. It was HTTP 1.1 because it's curl. And I spit out a 200 response. And so I could sit here and I could test this, and I could do all sorts of different things to test and see what happens if I type in something invalid, and it's just going to say that that's not going to work. I can also come back into my code and say, hello world's kind of basic. Let's change this again to hello sfloft. Come back here into my code, test that, and so, oops. Oh, I edited the wrong file. 1 second here. I got to remember to edit in the right directory. Take 2. That's better. I can live edit my code, and in this case, I don't have to stop and start the local utility. It's just editing the code that's running in that Docker container for me, and so all of that will work. Now, let's imagine that I was a really bad developer, and I changed, for example, here, status code 200 to cats. Now, cats is not a valid spec status code, for those of you who know HTTP. And so, no data. Well, that's strange. I can then go back over to the local window here, and I can see, oh, you know what? Global name cats is not defined. So again, kind of a silly error to make in Python. Then I could also come in here, and actually the IDE is smart, and it told me, hey, wait a second, there's something not right about this. There's other things that I could do here. I can actually use a debugger inside of Cloud9 to set breakpoints in my code and be able to test those with my serverless application as I am building it. I could also come in here once my application is working, and I can deploy from here. I can also go and pull down any of my live Lambda functions and be able to edit them and repost them again. So I can do all this from Cloud9, use SAM local for testing, and do all of that. So let me go ahead and change cats back to 200, which is a valid status code. Save it, cleans the error here. I can go and test this. Great, everything's working again. I could then go from here and deploy this function. So let me get into the right directory here. Oops. So I can run the SAM package command, which is basically going to take this code and zip it all up and put it up in S3 for me. It then goes and modifies my template file, and it creates a packaged template file, which is what I named it here, which is actually going to say that my code lives in this specific URI. So it takes that zip file, it puts it up into an S3 bucket for me, which in this case is just called Munns-code, and it has a hash as the object name. And I can come back down here to my SAM window, and I can do SAM deploy. Let me give this a unique name. 1 second here. SAM hello loft. And so from here, what it's going to do is it's actually going to say, OK, based on this template file, based on the code that we have just saved and created, go and deploy this into production in actual Lambda. Now, it's going to use the SAM template file in here now to deploy this to configure all of the services resources that we have. And so again, just coming back and looking at the packaged version of this, my timeout is set to 3 milliseconds. The outputs are defined here. It will show what happens from that. My single resource, which is my function, and then my API definition. And it should take just a couple moments for it to tell CloudFormation to create this resource and push this up. Cool. So down at the bottom here, it says successfully created / updated stack SAM hello loft. What I can now do is go back to my console. And there's a couple ways that I can find out more about this. I can go to the CloudFormation console. Oops, let me go in the right region here. This is in Virginia. I see that I have a stack here called SAM hello loft. I close the sidebar. I could find out all the various bits of information about this. So it has the name. If I had enabled something called drift detection, I could go into the events and see the events of all the actions that it took to create this stack. I can come to the resources, and this is going to show me all of the individual service resources that were created. So function, permissions, IAM roles, API gateway stuff, et cetera. I can see here the outputs. So I mentioned before that outputs are basically a thing that you define that represents what comes out of this function. And so I can see right here that I actually have the URI for my endpoint right here. So I can grab that if I wanted to. I see the parameters. In this case, there were no parameters that I passed in. And then I can go and view the template. And so this is the SAM template, again, as it shows up here. Just about 20 to 30 or so lines of code. And I can actually click on View Process Template. And this shows me the actual template if I had written it in CloudFormation. And look again how far I'm scrolling through this. This is easily 2 to 3 times as many lines of code had I actually written this in CloudFormation versus SAM. So again, here's the SAM. We can pretty much fit it all in a single window. Here's the raw CloudFormation. A whole lot more code, a couple times over the amount of code. There's another thing that we have. If I go to the Lambda console, I can go and click on this item on the left-hand nav bar called Applications. And now, one thing that we've done, so we've been building out this new Applications dashboard over the last couple months. We keep adding stuff kind of periodically to it. But if you launch a function with SAM or with CloudFormation, it will show up here. And so if I click into this, I get kind of a little bit more of a scoped view into the resources of this serverless application. So I see here that there are 7 resources. They're grouped by the major category types of Lambda function and API gateway. And this is the same information that I would see from CloudFormation. I can actually view the SAM template. So what was it that was deployed as part of this? I can come over here and see the deployment history. So if this was an application that I was iterating on, I could continue to see all of the deployments that had ever happened. And then I can see the monitoring and metrics information from this for both Lambda and API Gateway and any other resource that was defined in the SAM template. So this can become kind of a single go-to dashboard for information about this. Going back to overview here, under the API, I know that I have an API endpoint. Just open this up in a new tab. I have to throw in /hello. And then again, here's the text that we saw. Cool. So what kind of happened here? We started in this case, Cloud 9, but it could have been any terminal window. I had SAM CLI installed. I initted a new function, which created a base directory that had a SAM template and some application code. I used SAM build to pull in my application's dependencies. I then was able to locally test and iterate and debug my function. I was able to throw fake API calls at it, see the response, see what broke when I broke it, and then fix that again. Really quick, rapid iteration cycle on that. I was then able to package it up and deploy it up to, in quotes, the cloud, all directly from that CLI. Now, I did all of that just using the raw shell commands. Cloud9 actually has a fun little GUI that you can use to edit the SAM template and to do SAM local testing and stuff like that. But I wanted to show it just in the CLI because I could have done that in the OS X terminal. You could have done it from a Windows shell or from a EC2 instance in Linux or anywhere else that you wanted to. So SAM CLI, really powerful tool, great place to get started, and again, a lot of learning value there. Now, behind the scenes for SAM, the thing that takes those, what we saw was 30 or so lines of SAM template and turned it into about 80 lines of CloudFormation, is this thing that's called the SAM translator. The SAM translator is that transform construct that basically maps out the special resources that we have, things like globals, policy templates, the safe deployments capabilities, and turns that into the raw underlying capabilities behind the scenes. Now, back in the spring of 2018, we actually rewrote this from the way that it was originally written. It's now in Python. It's open sourced. You can go and you can pull at it. You can look what happens. You can read about it. You can also contribute. And so we've had some really awesome contributions from the community. A couple of these have gone live, have been really valuable. The one that's kind of on the your left-hand side, number 447, inline code for SAM templates. Really pretty cool. You can have a document that represents all the aspects of your function and your function code and just ship that and deploy that and not have to have anything more complicated. All sorts of stuff that you can do with that there. And so this is open source. The CLI is also open source. So back when we announced Ruby support, a different developer inside of AWS actually put the Ruby support into the SAM CLI before the SAM team had the chance to do it. So they were so excited about Ruby, they put that in, put in a PR, team merged it, awesome. So seeing lots of interesting stuff happen here in this space, and we continue to see more and more capabilities come into this. And so you can check this out. You can make issues, you can ask for feature requests, all this stuff in GitHub for the SAM CLI. Now I've talked a little bit here, again, we've seen the application repository. We saw the Magic 8-Ball app that came out of it. Again, what you can do with the app repository is you can share both publicly and privately inside of an organization entire serverless applications. So I could have taken this Hello World application that we just created and tested locally and published it up to the app repo, and you could have gone and then pulled that down and done whatever you wanted to with it yourself. And then what we announced at reInvent, again, just kind of the end of November, is this concept called nested applications. And so the concept of nesting is that you can basically relate different entire serverless applications to each other. And I think one of the best examples that we have for this is the lead product manager for API Gateway, whose name is Dougal. He was getting a request for a really basic authorization mechanism for API Gateway. And he said, OK, and we'll talk about this a little this afternoon. Where is it here? Yeah. API Gateway supports a concept called custom authorizers with Lambda. Basically, you can use a Lambda function to do authorization for your API. The people were looking for basic HTTP authentication, which is a really basic kind of old school way of doing username and password inside of web apps. It's not something typically encouraged these days, but people were asking for it, and he was trying to make an example of how easy it is. And so he wrote the code, published it in GitHub, and then made a serverless app repo application. And so anybody can now go and find the template for this. It uses DynamoDB to store username and password. And you can just go and deploy this. And so you can deploy this authorization mechanism, tie it into your API gateways, and glue it all together. Now, one thing that we did for the launch blog for this was show how you can have a SAM template that just references this app and basically say for all of your APIs, include this authorizer. And then that's not something that you have to write. So where we see a lot of organizations do is, let's say that you have a user management service already, and you want to integrate that with a serverless application. You could create a Lambda function that talks to your user system, and then tell everyone in the organization, this is the authorizer that you use if you want to build a serverless application. And you just saved everyone in your organization from ever having to write that code. And so again, you can really quickly and easily relate these two things together And that is kind of the power of nested applications. And so you could build really, really complex serverless architectures using all sorts of different applications together. Nested applications can refer to other nested applications, so you can get kind of interesting bits and pieces there. In this case, I've already kind of demoed this before. So you can read all about SAM. Again, we've talked about the templating structure today. Greatly reduces the amount of work that you need to do to build, to provision and manage these resources in AWS. We saw, again, that kind of 1 to 5 mapping of lines of SAM to lines of CloudFormation. You've got capabilities like safe deployments and globals and policy templates, all of the capabilities that are in CloudFormation for parameters and mappings. Then we saw the CLI being able to go from kind of 0 to full application running in the cloud, where we tested it, we debugged it, all of that locally before we deployed it up. You can find out all the information about SAM, the open source repos, documentation, everything else at aws.amazon.com/serverless/SAM. Again, SAM is the squirrel that you see here. That is SAM. So SAM, the squirrel, is our mascot. Think of it like the Docker whale and the Go gopher. This is our version of that. We're happy today, for those of you here at the Loft, we've got all sorts of fun stickers that we're going to put out on a table in the hallway here. And so make sure you grab some SAM for your laptop. I've got a little SAM guy here on my laptop as well. But again, you can find out a lot more about SAM. In terms of serverless stuff, as I mentioned earlier today, you can go to aws.amazon.com/serverless and find information and links to all sorts of different types of content. Again, up there in that kind of white middle header bar, you've got links to the serverless app repo, to developer tools like SAM, to resource pages, and everything else that you might need. If you're leaving us and not sticking around for the rest of the day, and my name is Chris Munns. I'm a principal developer advocate for serverless here at AWS, based out of New York City. You can find me at munns@amazon.com or at Chris Munns on Twitter. Happy to take questions there. For those of you here at the Loft, we're breaking for lunch for the next hour. For those of you who are live here on Twitch, I think we're switching to some other fun stuff here for a little bit, but we're going to be here later today and hope you can join us. Thank you again for coming today. And again, if you can stick around for the afternoon, we've got a lot more fun stuff to talk about. Layers and runtime API, deep dive into API gateway, step functions. So we're still kind of in the early part of our day here. But thank you again for coming.